morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Winda with another video. So now in this video, we are continuing on calculus. Okay, we have gone to calculus 2. What we are looking at was calculus 1. In addition to mathematics, we're going to learn about calculus all the way up to calculus 5. Okay, so this is calculus 2, which is applications of differentiation. We have started applying differentiation, and this video is going to teach you about increasing and decreasing functions. Okay, so if we have a particular function given by y is equal to f of x, so y is equal to rather f of x. So you draw a curve, okay? The function is represented by the following curve. A curve like that. And then we have another function, let us say another function, okay? Maybe y is equal to g of x, okay? Another function, like this. So, if you use common sense before I even explain anything, an increasing function, okay? If it's starting from here, a function starting from here, it's going upwards. It just keeps on going. It means that the function is increasing if you use common sense. And then if the function is starting from here, then it's going downwards like that. It's making a curve. It's going like that. It means it's a decreasing function. So that's the common sense you can use there before I explain anything. So we have y is equal to f of x there, and then you have a y is equal to a g of x there. What you have to know is for this function dy dx is actually greater than 0. Then for this other function dy dx is less than 0. Why is it so? If you have to find the gradient of a particular point along this curve, so this one, we have established that it is an increasing function. Okay? So this is a decreasing function. So this is an increasing function, it's a decreasing function. For an increasing function, dy dx is greater than 0. For a decreasing function, dy dx is less than 0. Why is it so? Because we have been given a particular point there, and if we draw a tangent line is simply a line that is going to touch the curve at that point only. As you can see there, it has only touched the curve at that point only. Otherwise, if you look closely, it doesn't touch the curve at one point only. But that's how a tangent line is supposed to be. It's supposed to touch the curve at one point only. To calculate the gradient of this point at that curve, this curve, okay, that point, we have to calculate the gradient. What do? We actually have to find the gradient of this line. The gradient of the line that we are going to find is actually the gradient of the point. Okay, that might sound confusing. So what I mean is that you have a curve, and then there's a particular point. You want to find the gradient of that particular point that is along a particular curve. What you do is you draw a line that touches that particular curve at that point only. That point only. So that line is called a tangent line. Okay? If you find the gradient of that tangent line, it's actually going to be the gradient of the point. So if you think about it, you have a slope, okay? For example, your house is here. You live there, right? Now, there is something about your house that you need to know. To get to your house, you have to go like that. So if you check this is the slope, okay? If you have done grade 9 mathematics, prior mathematics, you will figure out that this is a slope. But this is not any kind of slope. It is a positive slope, because positive slopes, they go like that. Okay? A positive slope is something that, you know, it requires a lot of resistance for you to get to the top. So for example, for you to go to your house, you need to really walk straight, you know. You need to really walk up this slope here. You're walking. So a lot of energy is going to be used there. Okay? That is what we call the increasing function. It follows that the slope will be like this. To be like that. Hope that's making sense. So for example, okay, for example, you have another point. Now this point is going to be here. Right here, just at the beginning of the curve, we draw a tangent line. Now if you look at that slope, it's still like this. So what should we know? If we were to calculate dy dx for this slope, you would figure out that it's going to be positive. Maybe it would give you dy dx is equal to a 2. You will see from the examples that we'll have. And then let's go to the decreasing function. So for the decreasing function, okay, if we're told to find the gradient of a particular point that is along the curve, for example, a point right over there, what do? The first step is that we draw a line that touches the curve at that point only. Okay, that's pretty bad, the way I drew it. So it touches the curve at that point only. Okay, so think of it in your head that it's touching the curve at one point only. So if it's touching the curve at one point only, what do? We calculate the gradient of this line. Very simple. The gradient that we'll find, if you don't know the formula to use, its gradient is equal to y subscript 2 minus y subscript 1 over x subscript 2 minus x subscript 1. Okay? If we calculate the gradient of that line, we are also at the same time calculating the gradient of that point that we have been asked about. I hope that's clear. Now look at the way the line is. Okay? It's sort of like you're going down. The slope is like this. So from my elbow here to the bottom of my hand, okay, the slope is like that. You're going down like that. So that represents a negative gradient. You don't need a lot of energy, right? For example, you're walking downhill. You don't actually need a lot of energy. But when you're walking uphill, you would have to use a lot of energy. But when you're going downhill, don't use a lot of energy. Okay. So for example, we have another point here. To calculate the gradient, we draw a tangent line. So if you see, the lines will be like this. They'll be like that, they'll be like that, they'll be like that. All of them are showing that it's a negative gradient. And if it's a negative gradient, it means dy dx is less than 0. Because dy dx is giving a negative number, it means it is less than 0. But we have a point where dy dx is equal to 0, okay? For example, this is a curve like this. Here, it is increasing if you follow it very well. Then to reach a particular point where it will stop, then to start decreasing. This point is called a stationary point. A stationary point is a point where dy dx is equal to 0. I hope what I've said is clear. Thank you so much for watching this video. This has been Cornelius Subinda with another video, and bye-bye.